Hello, my name is Cristian. I'm a group tech lead at Zendesk. And first of all, I wanted to say that talking at RailsConf is a dream come true. I've been coming here as an audience for a lot of years. Before, I used to watch presentations, in my home from Spain. So this is a dream for me. One thing I noticed watching so many conferences is that great speakers give you a little summary, in the first 2 slides. So you can go to another presentation later. No? So basically, I try to summarize my ideas on this topic in 2 slides. This is the first one. This is the second one. And it's a topic I think very, very often, and I don't understand why, because yes, Ruby has its own issues, but they are the same issues that you may find in communities like Python and Django. And moreover, I've written microservices in Java, and in the end, you find the same bottlenecks. So I literally developed a full explanation about from where the myth comes from. But for it, you will need to come with me and do some time traveling. By the way, this is Doraemon. He's a 22nd century robotic cat, and I promise he will come back. But well, now come with me to the year 2010. This is me with a fantastic jumper, I would say. And I was writing my first Rails app. It was a movie magazine, and I wanted the movie critics to be able to go write their own reviews, So I had to implement authentication. Authentication is a hard problem, as probably most of you know, hopefully. So then I decided I'm going to do a really thorough investigation on the issue, and I eventually found a solution. I guess that you know where I'm going. In this case, I found Device, or there are other gems, but Device is fantastic. I just made a very simple installation where really I was not understanding what I was doing, but it worked. And that was the point. It just worked. For the second part, authentication is a hard problem. But for me, for 22-year-old me, it didn't feel like that at all. For the second part, you need to time travel again with me and go to 2 years into the future, to 2012. I'm really proud of this picture. I wanted to show it. So I created a startup where I became the CTO, also known as the only engineer in the team. And we had to scale. We were successful, and we had to scale. And scaling is a hard problem. I think that's why you are here. Again, I did a very deep and thorough investigation, and I found this fantastic gem called ActiveScale. I guess that everybody here knows it. I initialized it using this parameter. I like to start with sufficient but not too much as a parameter too. And that was it. Everything was beautiful and nothing hard. I hope it wasn't too short. Okay. Not really. ActiveScale doesn't exist. I just copy-pasted some screenshots from Rails, and I changed the name, using Chrome. The thing here is that scaling is a hard problem, and it feels like that. There are no free lunches, like in so many features on Rails that 22-year-old me implemented a fantastic authentication system having literally no idea about encryption. That doesn't happen with scaling. So the problem is not that Rails doesn't scale. The problem is that Rails is so good, the learning curve is so smooth, that one of the few problems left for you to solve is scaling. That's when you discover, oh my God, software engineering is hard. Okay, before going to the main body of the presentation, I wanted to give some general ideas about the audience of this presentation. The purpose of this talk is an introduction to the problems of scaling. I'm going to give general ideas. And I will illustrate with issues that we found while scaling to a significant degree, I would say. I'm not going to get very deep into anything because I don't have the time. But please, actually, if you want to come to me later, I'm happy to talk. Another reason why I give general ideas is because when scaling, typically you don't find silver bullets. There is no way to fix all the problems in your application. Because like Tolstoy said famously, every time that every poorly performing system performs poorly in its own peculiar way. If I don't check your application, I don't know why it's slow. You may be having an n+1, you may be just trying to return too much data. Moreover, another issue that we find when scaling is that the amount of performance improvements that I can implement are literally infinite. There are so many ways to make your application faster. But at the same time, you are limited by two things. One is that you don't have time to implement them all. The second is that, you may find that the trade-offs are not acceptable. As I always say, if a feature is too slow and you cannot change it, you can drop it, and then it will be very fast. But that's typically not acceptable. Or maybe it is. Maybe you have this feature that is completely not used and is causing issues on database level. Maybe it makes sense to drop it. The reason why I want to make this talk for so many people here is because I believe that the size of the problem that the size of the data that we manage as Zendesk is pretty relevant, particularly for a Rails monolithic kind of a structure. We have quite a few microservices, but I would say our Rails app should be called a monolith. So Zendesk is a customer support platform. So I would say our basic data unit is the ticket. Someone complains about, oh, the Uber didn't come, something like this. So you have 16.3 billion tickets in total. That's more than twice the population of the Earth. That's a slide that you have animated, but I didn't know how. I wanted to make it double. And moreover, we're growing. Like a third of the data at Zendesk was created during the last year. This has an impact on the data that we have in our system, obviously. On our relational databases, the ones directly related to the monolith are around 400 terabytes. So it's pretty big. On the tickets table, obviously the tickets table has lots of associations and all that. We have 3 terabytes across all shards. And yes, sharding helps a lot, but still we have very big tables. The biggest tickets table is 41 gigabytes alone. And we have a table, events, that in one shard is 2 terabytes. So these are problems that are hard to work with, and interesting problems too. Finally, I wanted to comment about what I believe is the right mindset for a performance engineer. And don't worry, I'm not going to explain something elitist or anything like that. What I believe is that performance work is fun. It should feel fun. If you don't feel happy about, oh my God, I made this endpoint 100 milliseconds faster, maybe you should find something else. Seriously, it should feel fun. Yes. I would summarize it in the fact that a good performance engineer is a person that sees something like this plot. This is a real optimization I did a few months ago. And you feel like this. OK, let's have fun. First, I will start with what I believe is the most basic thing when working with performance, that is monitoring. You cannot fix a problem if you don't know you have a problem. And here we have a slide. Actually, this was made by someone that was supposed to talk with me, Anatoly Mikhailov. You can clap. Oh, great. Thank you. So here you see different ways of monitoring in different moments of the life of the application. One thing that I find that I get told usually is that monitoring can be expensive. Like you can get into trouble if you monitor too much. However, when working with performance, a lot of times what you're searching is patterns. And for patterns, you don't need all the data. You can sample. Zendesk, typically, for a lot of the data that we manage, we get to like 1%. And for that, it's good enough to see that where are the bad queries, what's happening there. The other thing I want to talk about are error budgets. And probably most of you are thinking, how is this related with performance? And error budget typically means uptime, how many times the application failed. Well, you can set error budgets for latency. You may decide, well, it's very nice that this endpoint returned at 200, but it took 30 seconds. Maybe that's not good enough. And at Zendesk, we have this. This is a real error budget. The column in the left is uptime, so the traditional error budget, the times that we return something that is not a 400 or a 500. And the one in the middle and the one in the right are the amount of times that the endpoint returning an acceptable, with an acceptable latency, and in a good latency. Obviously, what is acceptable and what is good is completely arbitrary. But that's OK. It's important for two reasons. One, to have a North Star, to say, OK, this endpoint needs to return in 1 second, and if not, we need to mark it as wrong. And second, because it's when you introduce a change, that is not a breaking change, but makes the application much slower, you won't detect it with an uptime traditional error budget, but you will detect it with a latency budget. Next comes the part that probably you were all expecting that I would focus on, database query performance. And don't get me wrong, that's probably what I do the most during the day, but I want to talk about other stuff here, like talk about performance from a different point of view. Actually, the talk was originally titled Beyond N+1, but obviously you have N+1s, that's probably the first thing you should fix in your application. The other thing I believe is very basic, but it's probably maybe even more important than N+1s, is using database indexes. I almost never found a good reason to not have a database index that is fine-tuned for your particular query. It may make writes slightly slower, but typically when you have a Rails application, you are much more heavy on reads than on writes, so it's going to be worth it. However, one thing that we found working with a lot of data is that a lot of times a database engineer is not some kind of omniscient machine and doesn't pick the right index. And that's surprising for us when working with databases, but you need to check. You can use explains. Actually, you can call explains directly from the active record, and it will tell you. That's important. Another, and this is something that happens all the time with ORMs, and particularly active record, is what I call greedy selects. Also called as I'm using select star all the time, even when I'm just going to print the IDs. This happens pretty often, and it can cause problems at multiple levels. Obviously, in the application layer, because you're instantiating a lot of stuff that you don't need, but even in the database. Database happens that if you have this huge table that has 40 columns, and has text columns, and has serialized Ruby objects, and you're fetching all the data, database may not be even able to keep all the data in memory. So it'll be writing to disk in the middle of a select. And that obviously has a huge impact on performance. Actually, this is the one that I showed before. This is an optimization we did using just Black, and it was a huge, huge impact. Caching. That's the other thing that everybody thinks about when improving performance. Here I made a very simple diagram with a miss. You get data from database, and then you eventually get a hit. One thing we found that works very well for us is what is called write-through caching. The idea here is that in parallel, you write to the main database and to the cache. Of course, this may not sound like a very good idea, because then you may have a cache that is almost one-to-one with database. But how we use it, in particular, is for the normalized, derivated data that is typically called from. Like you have a list of, 1,000 events that happened on a ticket, and then you need to mark, and then sometimes you need to return, the last time that an agent called Cristian participated. So instead of making this super expensive query on databases, fetching thousands of records, you can just mark it, have it in the cache layer, so it's ready to come back when the user asks for it. We actually did this recently. And here is another optimization. No? It was 40 milliseconds, and then it went down all the way to 3, 4, I guess. This may sound like I'm over-engineering, like, OK, it's 40 milliseconds may not sound like a lot. But again, scale. When you are using this 50,000 times per day, this 8 full days of computing time per year. And that's a lot of money. Moreover, this kind of complex database queries that you are optimizing for using this kind of cache tend to have high variability. That means that the median is much slower than the slowest 1%. And improving that is key, for two reasons again. One is that these P99 tend to be the ones that causes real database issues. They are the ones that tend to cause database incidents. And second, for the end user is a much better experience. The end user is not going to detect that the endpoint now moved from 200 to 250 milliseconds in general. it's going to detect if suddenly from that time he gets a response that takes 5 seconds. That's what generates a bad user experience. Finally, trade-offs about caching. You're adding complexity, obviously. It's another data layer. It's another point of failure. Moreover, caching isn't trivial, and I find that caching is so easy to use that people misuse it. Actually, this made me create what I call the Doraemon Paradox, and I told that Doraemon would come back. So this is Doraemon. Who knows who is Doraemon? OK, people of culture. So for everybody that is not here, that doesn't know who this guy is, this is a Japanese cartoon from the 70s. I used to watch it all the time when I was a kid. He's basically a robotic cat from the 22nd century who has millions of futuristic gadgets in his 4D pocket. So he has all kinds of machines there. And originally I started to think about Doraemon because this pocket is literally infinite. Like here you see him taking doors out, but he takes ships. He can get anything from there. So I thought, oh, most of people think that Redis is exactly like that. Like they put gigabytes, I don't care. No, it's pretty crazy. However, thinking about it, I realized that Doraemon is an incredible fable about software engineering, and I really mean it. Because all episodes have the same structure. So Doraemon came back from the future to help Nobita, who is a clumsy, kind of a loser kid, like 10-year-old kid, and he's always getting into trouble. So during the episode, he goes to Doraemon and says, Doraemon, give me a machine that will fix the problem. And Doraemon complies. He gives him anything. It's also so many things he has. But eventually, Nobita, that he's successful, but he starts to misusing it. Like Doraemon told, don't do this. He does it. And eventually, a much bigger problem than what he originally had ends happening. I believe that software engineers, a lot of us, tend to be a bit like Nobita. There are some technologies that seem so simple, that seem that it just works, that it tempts us to misuse them. So know the technology that you are using. Use it wisely. Next one is probably my favorite technique about scaling. It's the one that I didn't know much when I joined Zendesk. It's called cold storage. It's basically storage specialized in data that is never, rarely, or infrequently accessed. OK, you may be thinking, why? You just play me about cache, and you tell me that, oh, it's good to have a space to hold data that is frequently used, but it's adding complexity. Why would have something that adds the same complexity, but it's like an anti-cache? It's like data that I don't really need that much. Well, the reason is scaling. The reason is size. As I told before, we have quite a lot of data at Zendesk. And this obviously can be problematic from a software engineering point of view. There is a point that database optimizations may not cut it anymore. So there is a solution. What if I told you I can make those tables smaller? I can send the business back to the day one when it was smooth and you didn't have that many customers, but that meant that the tables were just nicer. Why not send part of the data to a different kind of storage so the tables become small again? Here you have a very basic version of Zendesk with a user that creates multiple tickets, and the ticket has multiple events. And after some time, you can mark that data as ready for archival. At Zendesk, what we do is when the ticket is closed, meaning the interaction with the user has been finished, we wait some time. I think by default it's 6 months, but it can be completely customizable there. And then what we do is we hard remove the data from relational databases. But don't be scared. We send it to a specialized ticket storage. For that, you can use a lot of stuff. You can use React. You can use, I like using S3 for this kind of stuff. And at the same time, because we need all those associations, we instantiate in a new table something called archive ticket. That's not the real name, but more or less. That is basically a skeleton to keep all those associations working. And also, it helps us to point to the ticket storage where the old data of the ticket is. This technique that I just described has a huge impact on how we think about data at Zendesk. 85% of our tickets are archived right now. That means that without cold storage, we wouldn't have 3 terabytes on tickets table. It would be more like 25. Also, before I said that we have 400 terabytes on relational databases, my bet, and I haven't made a calculation because ticket is a table that expressed through multiple tables, let's say. My bet is then we'll probably hit petabytes of data on relational databases. This technique, and I'm sure that all the engineers in the audience understand that, it has huge trade-offs. You are introducing multiple sources of data, and not only that, it's not like in caching that you still have your source of truth where all the data is there, even if it's slow. Here, you are breaking the source of truth in two. Suddenly, you don't have a relational database with everything. You may find that you need to change access patterns. You may need to have two endpoints, one for returning archive data, another for non-archive data. There is a lot of way around this, but it's rethinking the application may be necessary. However, I think we tend to underestimate how customers value performance. In general, I would say that customers prefer to have to make two calls or to have to access a different endpoint to get data from 3 years ago than to have an endpoint that is just slow. Performance is a feature. Next, and if you see, I'm going from more machine programming stuff to more productive ideas or more designy ideas, is designing a product around performance. And the next slides are for all the product people in the audience. I don't know if there are any. Well, maybe better. Product limits. Product limits in bold. And product limits in a very big letters. Yes, I know what you're thinking. My product is very simple, has this very clear use case. I don't like to put limitations on my users. Yeah, but once a platform gets to a certain size, you absolutely have no idea what's happening on database, except if you're monitoring. And even then, you can find people using your platform for things that you didn't design it at all. Moreover, you may be thinking that, no, I don't want product limits. But you still have product limits, because your product is an application that is running on a machine, and a machine exists in a material world. And machines that pass their limits end up like this. So you don't want to have a database meltdown and say, hey, my product doesn't have limits until the computer explodes. Please, product limits. Next one is, I love this one. And I think anybody that has been in a company for more than, 5 years has seen this. I call it the incredibly enlarging payload, AKA endpoints that return way too much data. So 5 years ago, you created this tiny little endpoint. It was an index, and you were returning 4 attributes per object. And then, some time passed, you moved to a different team, and then suddenly it's returning 40. You need to get a browser extension to parse it because it's impossible to read. And this is bad. The endpoint is suddenly much slower. You increase complexity, it fails. You don't know which one of the 40 attributes is failing. And you're also sending a heavier payload. And this is something that we don't think very often, I think, as software engineers, but it's significant. The price of parsing such an amount of data in the front end is heavy. There are good solutions, though, for this, using sideloads, using GraphQL. And finally, the last product part I wanted to comment is breaking down slow workflows. On the read, what you can do is breaking down that very slow request into multiple ones. And I know what you're thinking again. This is objectively slower. The same logic will have to be executed, plus network, plus middleware. However, what you are not thinking about is again, user experience. If your API is powering your front-end application, you need to remember that. The thing here is that you need to give a user experience as much functionality as possible. So you can make a first request that is fast and give some data and lets the user play with the application. And then eventually you make that query that takes seconds to fill the gaps. The user experience is going to be so much better. Second, on the write. So this is another write that suffers from feature creep. And originally, you were writing to one table, and now you're writing to 36. One thing you can do about this is just make it asynchronous. Make those writes asynchronous. So here, you see, there is a part of the write that stays in synchronous, and then we return 200. And all the rest of the data is changed via synchronous workers, or there is a lot of techniques. These at Zendesk eventually evolve into distributed systems, into full distributed systems. Typically, our monolith generates a Kafka event, and this is consumed by multiple microservices that at their own time will write on the database. However, eventual consistency can be painful. If you are used to your synchronous application, to your synchronous API, that's a very, very significant change. And finally, the last thing I wanted to talk about is what I call special interventions. It's all about doing things that don't scale. This program, actually, this picture, I think it was taken in a RailsConf a lot of years ago. So what is that? When I'm doing a special intervention, I feel like Captain Ahab, from Moby Dick. And the idea is to go, not to go to get a lot of fishes, but to get the big one, to hunt the whale. And because the reality is that for a lot of applications, a very small amount of power users or power customers are going to have a huge impact in the reality of the day-to-day of your data, of your database. Your SLOs will be very heavily impacted. We find that balancing shards to distribute all those resources is crucial. We're moving accounts very, very often at Zendesk. This is a real optimization that we did recently when we moved a very big account to a different shard, so it's more balanced. Moreover, something that we started doing recently is splitting accounts. The idea is that when a power user gets too big, or very big, they will have very clear separation of concerns into their own business sometimes. So it makes sense to just offer them the option to have two different applications, two different accounts, so they benefit by the idea of having a separation of concerns, and you benefit because then you can balance those database resources. Here, you have another result of a recent optimization with that. Okay. Finally, I have 3 minutes left. I did on time. I'm very happy. Conclusion. I want you to leave you with a few ideas to get home. It's about trade-offs. Beyond doing some very obvious things like adding indexes, some caching, N+1s, it's going to be about trade-offs. There is no such a thing as a perfect system. Just one that fits the best the current needs of the business. I think one thing I found very often with computer scientists is that there is a very excessive, what I believe is an excessive pursuit of perfection. Sometimes I say, well, we can change the product, we change this thing that doesn't have much impact, and the endpoint is going to be so much faster. And I feel like there's a rejection line that it's like, it's there, it's a hack. No, you need to find a trade-off. You need to accept the reality of this. I believe that we at the Ruby community are very good on trade-offs. We're special, I really believe so. That's why I stayed so many years as a Ruby developer. We are the community that optimizes for developer happiness. We know that a happy engineer, a happy programmer, is a more performant programmer that writes code faster and more efficient. And this is normal because Matt created Ruby for us to be happy. So that's it. Please go there and be happy.